So, welcome to the mobile application development crash course. Here we will see less slides and do more practical. Okay. Who's me? I am Dr. Abbas Malik. Did my PhD from France in 2010. Can speak multiple languages. My area of specialization in machine learning, data analytics, and the data mining. Also have good experience with programming, databases, mobile applications, web development, and all. These are some resources which are available. Links, the main resource for the Android development, you can see that it's an Android developer website. You can't find one book which can teach you everything. We have app development courses which are also available on the app development Android developer website. Java tutorial, because we are based on our programming language here, Java. Nowadays, the Google or the Android, they are pushing towards the Kotlin. Kotlin is a different language, but the point is because you already know the Java, and then maybe it will be a more difficult learning curve for doing the things in the Kotlin. Okay, so you need to learn a new language before you can jump into the Android development. Android Studio, that is the IDE that we are going to use it. User interface design, API reference, all those classes, references, details, documentations are there. Developer guides, samples are also there. So all these are resources that you can use during this course. Okay, this is our QR code that you can try to access. All lectures will be recorded. That's just like we are recording this lecture, and that will be available on that YouTube channel. So you can just access that YouTube channel over there. This is the important one. That is where you can find the slides. Today's lecture slide is already there. You can access that drive and you can download that lecture as a PDF. Okay, that's good. Time to start. So this is the mobile, in the past. People standing by the car, all that whole module is big enough. You can see on the left side that we have batteries and the receivers and the transmitters which are sending those mobile data. History, yes, that is what mobile communication looked like in the past. Then we come up with the zero generation, which is a radio telephone. Motorola and Bell Labs made them. Then we come up with again Martin Cooper from Motorola. They make a little bit more compact version of that mobile. Later on, cellular networks came in. Rather than the radio communication, they start working on the cellular networks, and then later on we come with the cellular network with the analog, and then later on we go for the digital one. Okay, so we go for that 2G, 3G, 4G. Now we're talking about, I think we are currently using the 5G, and now the research community is talking about the 6G, which may be 5 years down the road or 10 years down the road we will have that. But right now they are working on that, making their protocols and things. Nokia mobiles. I don't know how many people have used that one. Anyone in this room? Nokia mobiles, old one with the keypads only, no touch screen, even the black and white, black and white like this. And then sometimes you can also have a color screen, but it's very, very only just take a call, make a call, receive a call, or maybe you can send some messages, a few words or maybe some sentences. That's it. But later on, 2007, everything changed. Nokia out of business, and then we see the Apple iPhones, and then we see the Samsung, then other companies comes in with these touch mobiles. Development language, we are going to use Java. If I go back around 5-6 years, Java may be on the top, but still it is going down, but yet it is at the third place in the current world as well. It's not like a language is totally died or totally obsolete. Still, it is relevant. Third language or third mostly used languages in the world. So we will be using the Java language. We also have the other languages which help us to develop the mobile applications. Swift is only for the iOS by the Apple. Java and Kotlin, they are only for the Android development. We also have JavaScript. Again, these are the not JavaScript, these are JavaScript frameworks. We have a React Native, Quasar, and then there are many more which can help you to build the applications for the web, for the iOS, for the Android. And then you only just need to understand what are the JavaScript. I think that if you have already taken that web development course, then you know the JavaScript. And then you can build on that, and then you can learn from those things. We also have a Dart, which is a Flutter framework, again introduced by Google in 2017 or 18 it started, and then they are using the Dart language for their main programming language. So all these languages can be used for mobile development, but we are choosing the Java because you already have an experience with Java. You have studied programming 1, programming 2, data structure courses, and then you have used Java. So you are familiar with the language, so we don't need to teach you that one, but we need to teach you the skills which are required for the mobile applications. Again, Android is an operating system just like our Mac OS or the iOS or the Windows. It's an operating system, and it was introduced by a company which was very small, but later on that company was acquired by the Google, and then they have a habit to give their different version names based on some suite, some desert. Okay, mobile operating system originally from Android Inc. in 2005, later on acquired by the Google, and run on the phones, watches, tablets, TV, and cars. Even now we have inside our cars, Android Play, Apple Play, and that kind of stuff. Based on Java development language and the Linux kernel, the main base of that operating system is Linux, and then it has these based on the Java language. More than 1 million apps on the Play Store. I think that's now it will be code is released as open source periodically. The Android is by default is an open source operating system. It means that we can access the complete code, but once the Google has take over that company, it release but not the latest one. For example, right now I think we are talking about the Android 15. Am I right? Android 15 is the latest version. So maybe you can say that the Google has released the complete source code for the Android 14 or Android 13 a little bit back, because this is the latest version. So they also don't want to give the leverage to the the black the hackers and the bad people. If they can access all that source code, then maybe they can find out the loopholes in the system and then try to exploit it, and the big crashes of the cybersecurity can occur. So they are releasing the code which is a little bit outdated or which is a little bit back, but yet they are periodically releasing those codes. Okay. Starting with version number 1, we have the 1.1 to 1.5 Cupcake, then we have 1.6 Donut, then Eclair, and I think today is the latest one is the Android, and that is called Vanilla Ice Cream. Again, they are trying to have that habit to give that version names based on some desert, some sweet, something sweet. So all these a little bit history. Current level is 34. API, application programming interface. They started with the 1 and then 2, and then right now the current level is 34. Okay, these are little bit history. Android Studio, if you click on that link, you will download it and you can install it. Installation, I don't need to tell you that how. You are all computer science or the information systems or the software engineering students, you know how to install the softwares. Yeah? Android Studio, we have the SDKs, software development kit. Just like your Java, you have a Java development kit. So we also have the software development kit for the Android, Android development SDK 34, which is related to the current version, 33, 32, 30, and so on. So again, based on your requirement, you can install different type of different version of the SDKs. But definitely, we will try to use the latest one, which has more features, which has new, what you can say that facilities and the features which has been introduced in the new version. So you can, normally we use the latest or the second latest version for the development, okay, and then we have Android virtual device. We need to add a virtual device. If I want to test my application, how I can test it? Yes, we can connect our phones with the computer wirelessly or using the wire, and then we can test directly on our mobiles, but they also provide you a virtual Android virtual device. I will show you once we will start looking at the Android Studio. Then we can add. So we can add, when you install automatically, it will create one for you automatically. If you go for the default settings, it will just automatically add one virtual device. But of course, I will show you how you can add more virtual devices with different versions of the Android inside, and then you can test your different sizes as well, screen sizes and so on. So you can test your applications in different versions of the Android, in different sizes of the applications, and so on, different settings of the Android virtual device. This is our platform, Android architecture. Right at the beginning or the bottom or the base, it's a Linux kernel. We have drivers, audio drivers, we have binders, display, all things that has been related to the screen, keypads, Bluetooth, camera, Wi-Fi, USB, all these comes directly communicating with the hardware and helping you to all use that mobile. So that is our Linux kernel, which is actually governing or helping us to use that mobile device. Then we have the hardware abstraction libraries. Here we have directly communicating with the audio. We have microphones, or speakers, Bluetooth, communicating, connecting the different devices, whether mobiles, camera, direct hardware access. And on top of that, we have different hardware abstraction layers. They make some libraries, APIs, so that you can access different functions for the audio, for the Bluetooth, for the camera, for the sensors. Even you can build your own application which can help you to connect with some mobile device or what you can say that another device over the Bluetooth channel, and then you can communicate with that. Okay, so all these are hardware abstraction. They expose the hardwares for the programming at the upper layer. Then we also have OpenGL. That's more like on the if you want to build the Android, what you can say that virtual reality applications, augmented reality applications. So we have this. You want to access different features of the graphics. So all these are the libraries which are available here. WebKit is there. OpenGL is more related to the graphics. SQLite is more related to the databases, So all different libraries are there. We cannot cover everything, but we will try to cover a few of them so that we see how we can use them in our program and build the applications on that. Core Java libraries, Java runtime, and the core libraries, which are libraries from the Java, which help us to make the program or make the application in the Android Studio, or maybe you can use other, like VS Code can also be used to make the applications for the Android. And then how it is going to convert that whole code or the program into the application. So core libraries or Android runtime, we will talk more about the Android runtime, but these are the core libraries which are available in that architecture. We also have the Android runtime, and that runtime, we have a virtual devices, virtual machines. We can create virtual machine containing the Linux. We can create a virtual machine in the using the Windows or the Mac OS, or we can create as many virtual machines. We have the VMware, we have the VirtualBox, different applications which can help us to build the virtual machines. So consider that your application, one application, is considered as running in its own virtual machine or virtual environment. Every application that is running on your mobile, it is running in its own virtual environment, and that is Android runtime environment. Okay. Time to time, it was Dalvik before on the older versions of the Android. Now it has been replaced by Android runtime, and they are trying to use different techniques like ahead of time or just in time. They are compiling the code just in time before the use. Okay, so they are trying to optimize that kind of a technique so that we can run our applications very efficiently on our mobiles. Optimize the garbage collection. Again, you know the garbage collection when you are not using some area, some memory area, or the variable that you have declared, or the classes that you have declared, you are not using anymore. They are not accessible in the code. They automatically remove from the memory. Garbage collection. Conversion of an app, converting the app into a DEX file. That's what, the Android environment, you write your code in the Java language or in the Kotlin. At the end, they are going to be converted into the executable form, and that is our DEX file. And starting from the API 28 plus, they are trying to make it compact. Better debugging support in the latest versions. So Android runtime environment, every Android applications to run in its own instance of the Android virtual. Every application, if we have 100 application, 100 instances of the Android runtime are running, and the one application is running in its own environment. So we have a clear separation of these different applications from the other due to the restrictions, permissions, security point of views. Is it clear? Android runtime, again, apps are executed by the Android runtime, typically development workflow. App is written in Java, compiled in the bytecode, and a tool called DX converts that Java bytecode into a single compressed .dex class, and then later on that is going to be executed on the mobile application using the Android runtime. Applications framework, again, package managers, which is managing different packages within your application. For example, content providers, how we are going to save the files, how we are going to access the data, and so on. View system, the screen, how we are going to manage that screen. Activity, we have location, accessing the GPS informations. We have notifications are coming up. Resources, telephone, window. So there are different type of services which mobile provide us, and then we have the application package manager which are managing those services. Window manager, which is managing the windows, screens. View system, different visual components that are managed by the view system. Resource manager, we have the audio file, we have the video file, we have images, we have files. All these are resources, digital resources, or maybe we can say that the hardware resources, camera, microphone, all these we can save them, we can manage them. Activity manager, activity in the Android application is considered as one screen that you see on the face or the screen of the mobile device. So that is an activity. So how we can manage those screens, that is an activity manager. Content provider is managing the data, files, database, and so on. Location manager, GPS kind of a thing. Notification manager, which is managing the notifications on the lock screen or on the pop-up windows, and so on. Applications, again, we have a phone application in which you can use and punch some number, make a phone. GPS, map applications, you can locate yourself. Calendar application, camera application that help you to take the pictures or record the videos, and so on. So all these are applications. Browser, phone, contacts, home, emailer. So application components. There are four main components in the Android application. First one is activity, second services, third content providers, and the fourth one is the broadcast receivers. First, as I told you, activity is an screen that you designed for your application. That one screen that you are designing is an activity. It is also an entry point into your application. Normally when you write a Java program, what happens? Whenever you execute your program, what happens? Where it starts? Main method. You have write some other method. Is it possible that through the other method you can start the code? No. Only one entry point or one starting point for your application is the main method, and if you want to access other things, it will be through the main. But here in the Android applications, you will have multiple entry points. Remember the web pages? If you know exact address of the URL of the web, what happened? You can just type that URL in your address window, address bar, and then you can directly access that page. You don't need to go from the home and then click, and then go to the page. No, you can directly. But point is, if you know exactly that the URL, Universal Resource Locator, or the address of that page, then you can access that page directly. The same is here. We have multiple entries into the website, so we also have the multiple entries into the applications. For example, you open your gallery where you have videos, and then you say that I want to share. What happened? It opened up you want to share it via email, you want to share it via Messenger, or via Facebook, or via WhatsApp. And through that, you can just directly open that a specific activity or the screen in that application, and you can open. So you are entering that application through a different way than the normal one. WhatsApp, you have an icon on your home screen. When you click on that, it will automatically open, and then it will show you the. But if you are opening, for example, you are sharing your image, and then you say that I want to share it via email, what happened? It does not open the main window of the email, maybe Gmail or the Yahoo Mail or something. It open a composed activity or composing activity or composing screen, and automatically attach that image with this email, and then you just need to type the email address and then write the or optionally write the subject, and then you press send button, it will send. So different activities can be used as an entry point to your mobile application. This is not fixed, only one place you can start your application. Entry point for an interacting with the user presents a single screen with the user interface. Track current activity. This is the current activity, what is on the screen. Stack previous activities. You know, you are on one screen and then you go to the next screen. What happened? The previous screen is being pushed into a stack. Next, you go to third screen. Second is also pushed into the stack. When you go up back button, the second will come again back, this first window. So it is stacked. One activity that shows a list of new emails, other activity. So here you can see different type of activities, and we can enter into this application through any of these activities. Clear? Any questions? So each activity is an independent of each other. Photo app can start compose an email address, we already talked about, and every activity that you are going to design, it will be a base class. The parent class will be an activity. If you click on that link, it will take you to the API documentation for that class. Services are more like, you know, if you want to download something, you want to GPS service, you want to mobile service, all these are the services. General purpose entry points for keeping an app running in the background. For example, GPS, do you know that the GPS is already always working in your mobile? In the background it is working, it is providing you a service, locating your device, you know. No user interface. Normally services, they don't have the user interfaces. Music is also running, and sometimes they also have the interfaces, like music player. It also have the interface, but it can also in the background running. Okay, sometimes you know it is running and sometimes you don't know it is running. Music, you are listening, so you know that something is running in the background. GPS, you don't know it's running or not. So sometimes it is visible, sometimes it is, we know that something is running in the background, but sometimes we don't know. So these are the services. User aware of the services. I mean, we know that service is running and the user is not aware of the services. I give you the example. Again, if you want to build a service, then it will be, the base class will be a service class. The object-oriented programming concepts, parent class, child class. So whenever we want to make a service, we will make a child class for this service, and then it will give you a lot of features and the facilities automatically there, and then you can write your own customized code for that. Broadcast receiver, they are more like notifications. You are putting your mobile in the aeroplane mode, broadcast to every application. What we need to automatically turn down the cellular system, turn down the Bluetooth system, Wi-Fi system, turn down automatically. Of course, you can turn it on later on, but yeah. So enable the system to deliver events, deliver notifications, allowing apps to respond. Apps send or receive broadcast messages, notifications. Broadcasts are triggered by an event. Aeroplane mode is on and off, device is less than 5% battery life, fully charged, internet service is available, Wi-Fi is connected or not connected. So all these are events. So based on that, we can do different type of broadcast. An entry point to an application, again, broadcast is also an entry point to your application. Through the notification, you click on the notification, application starts to show you that specific message or something. Okay. Again, two types: broadcast, system broadcast, which is sent by the system itself, and then we also have the app broadcast. Normally, we don't have user interface, only display a notification. Implement as a subclass of the broadcast receivers class. Content providers, data. Data is always important. Whenever we are making a software or application or the web development or whatever you talk about, one part is the visualization, user interaction and user interfaces and so on, but the other main part is the data. So of course, in the mobile applications, we also have a data can be a file, data can be a database, data can be so to manage those things, we have the content providers. We can manage the data through the content providers and an abstraction on a data. SQLite is a database, a very light database, not like MySQL or something, a light database management system which is automatically there in the mobile applications or mobile devices, and then we can exploit that. So we have SQLite libraries, we can just add the tables, create the tables and so on, reading the table, running some queries on it. So through that, so abstraction is there. Again, we have a database, we have the application which is managing, or the content provider. Our application can just communicate with the content provider and it will access the database on our behalf, and then we can use it. Contacts. We have a contact application where we have all the names and the mobile numbers and the email addresses or addresses and so on. That is also a data that we are managing. For system design, content provider is an entry point. Again, content providers, services, or the broadcast receivers or the activities, they are entry point to starting point to your application. App map its data on a URI, universal resource identifier, and then we can make it. So if you want to implement some content provider, then of course you need to create a class which is providing but normally what we do, we have the abstraction SQLite, we are going to use directly with that. Yes, if you want to make a content provider by yourself, then you need to implement that kind of stuff. Messaging between the components. Activities in one application, we have many activities, activities independent of each other, how they can communicate. We have the intent object. Intent is again a class which help us to communicate between different components of the same application, or maybe the components from the other application. So that is the intent. You know, when I say open your gallery, select a image and then say I want to share it, and then you open that WhatsApp. So these communications are being handled through the intent object. Okay. Several ways of communication between the components. Starting an activity, we can start an activity. Starting an activity in an application, in the same application, or maybe in another application. Starting a service, or delivering a broadcast. The aeroplane mode is on, automatically Bluetooth is off, automatically wireless is off, Wi-Fi is off. Why? Because those applications are receiving, continuously trying to listen to that receiver. That events comes in, it has been broadcasted by the system to every application which can listen that kind of a activity, or that kind of a event, or that kind of a notification. Receive it, and accordingly they are making a response to that event. Okay, delivering the broadcast. Two types, explicit and implicit. When I say share, what happened? It gives you options. You want to email it, or you want to send it via Facebook, or you want to send it via WhatsApp, or you want to send it Messenger. So it gives you the options. We are not telling that which specific way we want to share. We say we want to share. How? We don't know. So that is called implicit. Does not specify the component, does not specify how, implicit. And then the system is giving you the option that these are the different ways that you can share the things. Sometimes it also say you save it in the drive. Yeah, okay. Implicit. Does not specify how you want to share. But if I say that I want to share it via my email address, then it will open directly the email composing activity or the screen, and then you can start. Now we are telling a specific way to share, then we call it as explicit. Okay. So when it is what you can say that implicit, it means the activity A, it sent intent, the Android system receives it, and then based on the knowledge about the applications which are already installed on the mobile device, it is say you, okay, these are the 4 or the 5 possible options which can help you to perform that action that you want to do it. Then it will give you the options, and then you can select, and then it will start that one. But if it is explicit, then this system is not coming down here. It is directly communicating with the other component that you want to start or you want to execute. So the system will go away in the explicit one. Okay? Let's build our Android application. How? Where is my, this is, okay, you can't see it, so let me, this is the references and the last slide of our slides. So let me finish that. Okay, now I can just go to my Android Studio. So when you have installed the Android Studio, first time you are running, it will show you something like this. And what we want to do, we want to create a new project. So new project, and here it is asking me, you want to build for the phone or tablet, of watch, Wear OS, watch, television, or automotive, or the cars. Of course, right now we will stick to our phones or the tablets. And then here I am going to select this one. Why? Let me go with the empty activity, which is by default selected. If I say next, it does not show me any option to select the language, that whether I want to do use the Java language or the Kotlin language. by default it is setting to the Kotlin and it will start making the application with the Kotlin. But we don't want to go with that route. We want to start the development with the Java. So I select this one, empty views activity, okay, and then I click next. And now here the first thing is I can give a name. So for example, our first app. The second thing is here, package name. This package name is unique for all the applications in the world. Of course, if you are developing in your own computer, only it exists in your computer, there is no conflict, no problem. But normally what happens if the companies are there, normally their email addresses or their websites are unique. So we can say that, for example, I say edu and then I say PSU and then what I say CCIS, that is our, and then it is information system department. Okay, yeah. So now I can know that this is going to be a unique, because if you want to publish this application on the Android, what you can say, the Google Play or the Apple App Store, then this package name must be unique in the world.
How will I know it's unique?
Normally as I told you that if you are using a specific domain name and kind of a things, it will automatically become unique because nobody is going to use your domain name to make the applications, And then this one is the location where our Android project is going to be saved, and here it will give me the options. I want to develop using the Java or I want to develop with the Kotlin. That video is available, so you can download it. You can see it on YouTube. Okay, so I select Java, of course, and then here it give me a few options. You want to make it for the Android version 14, and then look at that. It can only be accessible. This application is only applicable or you can be used on 30% of devices. But if I go back like Android 10, then it 81%. And then if I go back this one, 93%. So if we are now in this one, it's a minimum SDK. We are telling that we are setting that our application is going to be supported or going to be used by the older versions up to this point. And that is the minimum version of the Android which can run our application. If we go back, further back, like this, 100%. But the point is, this is a version 4.1, Android 4.1. We are at 14. So what will happen if you go like this? Maybe there are a lot of features, new features, which are not implemented at that time, so you can't use those features in your application. So you need to find out a balanced way. Maybe I can say that go back to 10, 81%. Okay, no, go to 8, 95%. Okay, I can live with that. So make sure that you are selecting this minimum SDK appropriate enough that the features that you want to use, they are supported by that minimum level of the SDK. If it is not, then of course you need to increase that minimum SDK level. But that will tell you that how many percentage of the devices which exist in the world they can use. I would say more than 70%, that depending on which features that you want. If it's a very basic feature that you want to use, okay, go for the 4 or 1. I think the minimum is say that only 4.1, not even 1. Go for the 8, 95%, okay. Understand? So minimum, yes, once you have done it, yes, we can change later on as well. We can change, okay. But this is what we are selecting. Name, package name, location where you want to save the project, language of the development, then the minimum SDK that you want to develop, and then here it is recommended, so you can go. I would say that DSL or doesn't matter. If you go for that, again, that's also possible. That's more like an older version, that's more Java based, but doesn't matter. Okay, I select the older one so that we can still remain in the Java world. And then when I finish it, now it has created, and now it is trying to managing those files, importing the first Gradle project, and then trying to create that project for us. And once it is done, I will